Alright, this video is about solid geometry, and we're going to be classifying three-dimensional figures and then using nets and cross sections to analyze three-dimensional figures. So first, some vocabulary. These three-dimensional figures can be made up of flat or curved surfaces. The flat surfaces are called faces. Like each side of the object is called the face, and then we have the edges, which are the intersection of two faces, or each straight line that you draw when you're drawing it are the edges, and then the vertices are the points of intersection between three or more faces. So each corner of the shape is a vertex. Now, when we're naming these, we name them by if it has two parallel bases, if it has a top and a bottom that are the same, then it's called a prism. All right, in the top and the bottom here, the bases can be any polygon that you want. This one happens to be a triangle. Okay, it's called a prism. Now, if the bases are circles and there's two of them, then it's called a cylinder. And if there's only one base, and instead of going to the same base it goes up to a point, we have a pyramid. And if that base is a circle, then it is a cone. So a cube is a prism with 6 faces, all right? And then the other prisms and pyramids are all named by their bases. So if the base on the base here happens to be a triangle, so it's a triangular prism. Or the base here is a triangle again, but this time it goes up to one point. It goes up to one vertex, so it's a pyramid, triangular pyramid. Okay, so you just look at the shape of the base and name it like that. Rectangular prism. This is a pentagon. It has 5 sides. Pentagonal prism, hexagonal prism, and so forth. So when we look at these shapes, you should be able to classify them and to name the edges, vertices, and bases. So first of all, what is this? Well, the base down here has 1, 2, 3, 4, 5 sides, so that makes it a pentagon. And since it all goes up to one point, up to one vertice, so it only has one base, it's a pyramid. So we have a pentagonal pyramid. The vertices of the pyramid are all of the corners, so all of the letters here, A, B, C, D, E, and F are all vertices. And then let's name the edges going along the bottom, all the way around the bottom. The edges would be A, B, B, C, C, D, E, D, D, E, E, A. And then going from the bottom up to the top, we have the edges A, F, B, F, C, F, D, F, E, F. Okay, and then at the bottom, we already talked about this base. The pentagon at the bottom is A, B, C, D, E. All right, this one has a circle at the bottom. This is a cone. Okay, and the vertice, it only has one vertice. The one vertice is point N. Okay, and then it doesn't have any, actually none of the, this is a circle here, it doesn't have any straight lines, so it's not going to have any edges. Okay, however, the base is a circle. Circle M is the base. Alright, now how about this one? This one has this green triangle on top. It's the same as the green triangle that you can't see that it's sitting on. Okay, so it's a triangle, and it's a triangular prism since it has 2 bases. The vertices, go ahead and name each of the points. So the vertices are along the top, T, U, V, W, X, Y on the bottom. And the edges, first naming the edges around the triangle on the top, we have TU, TV, VU, and then the edges going horizontally up and down here, we have TW, UT, VY, and then along the bottom triangle we have WX, WY, and YX. Then the bases, there's 2 triangular bases, right? We have the triangle on the bottom and the triangle on the top. So triangle TUV and triangle WXY. Alright, next up we have nets. So a net is a diagram that can be folded to form a three-dimensional figure. A diagram that can be folded. So it's a flat representation of a three-dimensional object. To identify the three-dimensional shape from the net, you just look at the number of faces and the shape of each face. So this one you can see how many faces are here. Well, there's 6. 1, 2, 3, 4, 5, 6. And each of them is a square. So you say, oh, okay, what shape has 6 faces that are squares? It must be a cube. So the net has 6 congruent square faces. It forms a cube. How about this one? What does this form? Well, we only have one circle here, so we're going to have one circular base. So if it has one base that's a circle, it's going to be a cone. And you can imagine this folding into a cone, like if you think of this top A, this top edge here being folded up around to match up. So fold point A to point B. But don't fold it flat, kind of let it bend. Bend point A to point B so that the point in the middle here is going to be the vertex, the very top of the cone. And then this circle will be the bottom of the cone. Okay, we can fold this one into a shape by bending each of these triangles on the sides up. So if we bend each triangle up to the center, okay, and bend this triangle up to the middle, okay, we would have a triangular prism. Triangular pyramid. We have a triangular pyramid. Great. And how about this one? We can kind of take this rectangle and make a tube out of it, and then these on the sides would be like the ends of the tube. So we're going to have a cylinder. Okay. So next we have cross sections. A cross section is the intersection of a three-dimensional figure and a two-dimensional figure. So a plane is cutting through, like knife cutting through our three-dimensional object. So here we have the green plane, which is our two-dimensional, okay, cutting through the three-dimensional cone here. What is the cross section? Where do those two intersect? Well, they intersect at the point. So this time it's only intersecting at a point. Okay, where do they intersect now? Can you describe the cross section, which is where they intersect? Well, the place where they intersect is this red area right here, and it's the shape of a pentagon. The cross section is a pentagon. Okay, here the cross section is cutting right through the middle, and it's forming this hexagon in the middle. Okay, the cross section is a hexagon. Okay, well now if we had the same cone from the first one, but this time we're slicing it directly up and down, you can see that it's going to cut the cone, it's going to make a cross section that's a triangle. Okay, now let's say that we have a piece of cheese that's a prism with equilateral triangle bases. How can we slice the cheese to make first an equilateral triangle, and then we're going to slice it again and see if we can make a rectangle? Okay, first of all, what does a prism with equilateral triangle bases, look like? Well, we've already seen one of those today from the previous example. This is an equilateral triangle that's green, and we've got one on top and the bottom. So imagine a piece of cheese that looks like this, and now we're going to try to slice it to make an equilateral triangle. Okay, well if the top and the bottom are already equilateral triangles, if I slice it right through the middle, I should get an equilateral triangle. So, in order to make an equilateral triangle, we can just make a cut that's parallel to the base. Okay, well, how can we make a rectangle? Okay, well to make a rectangle, I need to make a straight up and down cut. I need to cut directly up and down, and I can make a rectangular cross section. Okay, how can I cut this cube to make triangular faces? Well, in order to make a triangular face, I'm just going to need to cut off a corner. Alright, if I just slice a corner off, I can make a triangle. Okay, and great. So we have classified shapes, named their parts, and talked about nets and cross sections. Good job.